My name is Guangzhou. I'm from Alibaba Cloud. Our public cloud service for Postgres and MySQL has been running more than 10,000 of our instances. I'd like to share a few things from my own experience on building such a service. Here is a list of what I'd like to talk about today. Hopefully, it could be useful for you. I'm from the Alibaba Cloud RDS team. The Relational Database Service team covers MySQL, Postgres, and SQL Server database. We handle almost everything about the RDS product. Here is a highly simplified architecture for our service. Only the relevant components in my talk is shown here. We have used the server load balance to provide a virtual IP to end user. The user can connect to his instance with the IP, and we have normally two nodes, the master and the slave node. They are located in different hosts. We have the high availability component. It detects the availability of the master and trigger the switch, the failover between the master and the slave. We added the proxy layer. We have done something interesting with the proxy. So I will talk about it later. So first, the resource isolation. One of the key decisions we have made during the early stage of our service development is that we choose to use the bare metal machines. No VM, no network storage. We have to locate up to hundreds of instances on the same host. This way enabled us to take full control of the whole stack. It minimized the dependency, making the SLA and performance predictable. And it also enabled us to control the resource allocation. We have a component that keep on monitoring the resource usage of all the instances and all the hosts. And it will trigger the relocation of our instance as needed. Of course, we use a C group for the basic isolation. We created different C groups for different instances. There is a trick here. We separate data and the logging disk into different disks. We strictly limit the LPS capacity of the data disk, but we lose the limit of the logging disk LPS. For example, we may limit the LPS of the disk limit, for example, to 500 LPS as labeled in the by page. But we enlarge the limit of the logging disk to maybe 5,000 LPS. So why did we have to do that? Because a strict limit of the log disk LPS on slave, it can result in a very long replication lag. On master, it could easily even cause a failover switch because the lower limit of LPS and the heavy write could, in combination, easily cause the master not writable. And some cleanup work inside the database have required the heavy write I/O. However, that should be finished as soon as possible to make sure the instances are stable. Of course, we do that for better write performance. So why were we able to do that without hurting the stability of the whole system? Because we think no one will consistently be writing data to the database at a very high speed, since there is an upper limit to the capacity a user can use. And we think the database storage is somewhat expensive. So no one could insert data at a very high speed for 20 hours a day. And on the other hand, user need to buy more storage capacity if it keep on writing data heavily, because the storage for the bin log or logging files I charge, if it writes too heavily, the file will be accumulated inside its instance. So he have to buy more storage capacity for its writing. So with this reason, we have lose the limit of the logging disk LPS. And finally, if we found two different instances doing the heavy write on the same host, we can relocate one of them as needed automatically. Okay, for disk usage, we regularly collect the disk usage of each instance, and we'll lock down those who go beyond the disk usage limit. We added a switch for locking down the instance. With this switch enabled, only read access is allowed. Any write to the instance is not permitted. But we allowed the drop or truncate command to give the user a chance to decrease its storage usage. Okay? For privilege management, we kept the super user rule from the end user for security reasons. But the end users keep on asking for more privilege from the super user privilege set. So what we do is creating a new rule and assign it to the end user. With this rule, the end user can manage all of its data, no matter whose data, which user owns this data, and allowed this rule to kill sessions or set parameters. So this is a user experience issue. Okay, we have been facing some critical issues, which took us some time to resolve. For example, the out-of-memory issue. I'd like to know who of you has observed the out-of-memory issue in your system? I see a lot of. Yeah, this issue has been frequently observed once a time. But the out-of-memory is not so bad. What makes it worse is it will trigger the operating system to kill the instance. And this makes the instance not available for a while. This is bad. So how to minimize the impact of the memory? So we have found an interesting way to handle it. We created a separate public C group on each of the hosts. And there is an agent keep on monitoring the memory usage of other C groups. When one of the C group has a very high level memory usage, we will move some of its process into the public C group. In the meanwhile, we will send signals to this process. Then this process, on receiving the signal, will cancel its ongoing query and read the error message to the end user to tell him that the memory is not enough. So then, finally, the memory goes down, and we can move it back to its C group. So this way, we avoid the OOM queue, and tell the user that they have to handle the OOM issue. Okay. Another issue is the L stall. When it occurs, all operations are freeze, but the L usage is very low. So how could this happen? We found out it's because we use the ext4 file system, and it has a buffer for metadata. When the buffer is full, so someone will flush the buffer, but others have to wait this one to finish the flush. So that causes all the write operations are blocked. So how to resolve this? We have changed the mountain option to write back, and we have changed the Linux kernel to start up a standalone kernel thread to flush the buffer. Okay, finally, let me talk about the proxy layer. With the proxy layer, we have provided a built-in connection pool, which is transparent to the users. So when the disconnect, the backend connection is kept. So when another new connection request came, it will reuse the backend connection. So we have changed the database kernel to hack and enable such a connection pool. And with proxy, we can have the transparent switchover. Transparent switchover is a process that does the switchover without breaking existing user connection. Here is the process. When we do the switchover, the proxy will hold on any new request, and it will recreate the connection based on the slave. After the switchover is done, the proxy will let go any new request. So user must see its connection not broken. Okay. I have to go quickly. Okay. The final thing we recently do with our proxy is rewrite auto-routing. The proxy layer will pass the incoming SQL request. If it found it read-only, it will route the request to one of or more replicator, read-only replica. So if it is could involve any write operation, the request will be routed to the master. So this way, user can scale out his instance without changing his application. So that's all I have today. Thank you. So any question? Okay.
So it looks like you use some of the open source software, like FTP proxies or some open source. How much customizing to the kernel do you guys do? Because you mentioned that you were looking for
No. The proxy is was developed from scratch by our team, and yeah, it's similar. In some sense, but we developed it from scratch. We reference the other proxies design. But we root it ourselves, and it developed with language Erlang, you know. Yeah. As I said, we have a monitoring system to find that, to detect that, and we must be moving one of the instance. Yeah. We move it by 2 or 3 times, 1 or 2 times the switch over. So the time of the switch could be short. See, because it involved some switch over, right? So connection could be broken for that user. So okay. You mean the disk usage quota? Mm-hmm. Yeah. You have a quota. You pay. You can pay as you go or pay per month. And we have a different configuration for the user to choose. So, but the disk usage can be buy separately. So you can buy a small one at first and enlarge the capacity as you go.
So if I reserve my own quota, then how can it happen that I can overuse it?
Mm-hmm. Yeah. We have to handle that. When that happens, we have to do we call the movement of the instance from, for example, if on one host the disk it's used out, we have to move some large instance from here to another idle machine. We do that with we first move the for example the slave to another machine. Then the slave can connect to the master. Then we become then it become a one master to slave configuration. Yeah. Then we can switch the master to the new slave. Yeah. After that, we can choose to recreate a new slave or use the old slave. Okay. So from the view of the user, it's just say one time switch over. So that might be acceptable for him.
How long does it typically take to create a new slave? Or what capacity?
Mm-hmm. You quickly create a new slave.
Yeah. So you can create the slave in just 3 minutes or 2 seconds or 2 hours?
No. So for large instances, it takes hours. We have to copy data from the master or from the slave to another machine. Yeah, that it takes hours. So we have the capacity limit of usage of disk. So the max instance has to be under the 2 terabytes. Right. Okay. Sorry, I'm not getting.
For MySQL, when you don't have roles available, except in MariaDB and MySQL 8, how are you handling not giving you
I try to. You mean what engine we are using for MySQL?
Yeah, but specifically, how are you handling restricting privileges in MySQL?
Okay, I see. So we change the kernel to add some privilege check to the rules. Okay. I'll give you more details. Yeah. Okay. So you can find me in the Alibaba booth in the exhibition hall. So we can talk there. So thank you.